effects and fragment stages, Unity's render pipelines, and GPU's role and PBR. In Module 2, we got familiar with the shader graph UI, an essential node like color, vector, and texture, including tiling and offset node. Now in the Module 3, we are diving into proceduralism and animation. Our goal is to create patterns and animations right on the GPU. To do that, we will using key procedural nodes, symbol noise, Voronoi, and gradient. We will also learn to manipulate UVs for cool, distortion, and warping effects. And we will master the Fresnel step and smooth step nodes. Finally, I will show you how to keep your graphs organized with groups and subgraphs. We have got a bunch of awesome projects lined up, so let's get right into it. Playing on texture maps for color, normals, and even the blind mask, we can leverage infinite patterns. In the previous video, we explored using texture maps extensively. However, this approach opens up the possibility of creating diverse visual effects without the need for any textures. This video explores procedural noise, the underlying technique behind numerous visual effects like flowing lava, magical energy, realistic clouds, and grainy wood. Procedural in this sense signifies that the pattern is created through a mathematical formula, rather than using a pre-existing image file. A texture is a noise-generated pattern appears on the right. Upon zooming in, the texture becomes increasingly pixelated, whereas a noise pattern preserves its detail even at the infinite zoom levels. Vector textures offer three key benefits over regular textures. First one is infinite detail. Unlike standard textures that pixelate upon close inspection, vector textures maintain clarity at any zoom level. Their patterns are mathematically generated for each given coordinate. Second one is low memory usage. Since no texture file is used, the memory footprint is virtually zero. This contributes to better performance and smaller build sizes. Third one is easy animation. As mathematical function, vector textures can be easily animated by altering their inputs over time, allowing for dynamic and evolving patterns. The Unity shader graph incorporates two primary noise types, value noise and gradient noise. Value noise is generated by assigning a random value to each point on an integer grid and then blending or interpolating between these points. This process results in a blocky or chunky pattern. Despite its less organic appearance, it's computationally very fast. This type of noise can be used to create a more digital, grid-like or less detailed aesthetic. Gradient noise is frequently used with the Perley noise being a well-known example. Unlike value noise, which assigns random values, gradient noise assigns a random direction or a gradient at each grid point. This results in a more natural flowing and organic texture, making it suitable for simulating natural phenomena such as clouds, fire, water, and smoke. Now create a URP lit shader graph. First create a symbol noise node followed by a gradient noise node. To visualize the classical voice noise, connect the output of the symbol gradient noise node to the base color instead. Observe the resulting material. It appears smoother and more organic, resembling clouds. This demonstrates the key difference between the two noise types. Gradient noise produces a much smoother visual outcome. The scale input controls the noise zoom level. Higher scale values result in a smaller, more detailed pattern scale on the blackboard with a default value of 20. Drag this property onto the graph and connect it to the gradient noise. Adjusting this single value will then control the effect, ranging from large gentle waves to fine grainy details. To animate the noise, utilize the UV input of the noise node by creating a time node followed by a tiling node. Connect the time node to the offset input of the tiling node. For unidirectional scrolling, such as vertically, create a vector to node and set its value to 0.20. Multiply the time nodes output by this vector to know. Finally, connect the tiling nodes output to the UV input of the gradient noise node. This setup produces a visual effect resembling rising smoke or flowing energy. In this straightforward manner, an infinitely looping animated texture is generated entirely from scratch, serving as a fundamental building block for numerous sophisticated effects. Today, we see the power of procedural noise. Procedural noise is a pattern generated by math, not a texture files. It offers infinite detail and is very performant. Thanks for watching. Now that we know how to generate these patterns, in our next video, we are going to use these techniques to create more powerful visual effects.